It is? Okay. All right, Matthew and Noah, I'm sorry I forgot to start this, but I will send you these notes that have the answers in them. But I just made a couple of comments for, oh, hey guys, a couple of comments for you to definitely know before you take your test, is that in your book, it has you do several of these freezing point, depression and boiling point elevation problems. And they have you using the KB and the KF of water. You should have that memorized from doing so many problems that are assigned in your book and in your homework, that you should know the KF and KB of water. You'll need it on the test.
What if I don't want to do depression problems?
Okay, so you're always going to be given enough information, right, to where you just have to solve for one item. You just have to be able to read those word problems and figure out what is what. Okay, so, all right. Other examples of boiling point elevation is antifreeze solutions in your car, and
In a car or your car?
in anybody's car.
In car.
Okay, so knowing what I is, let's do some examples of I. So I tells us how many particles does something dissolve into. And you should have enough information, chemistry knowledge now, where you can solve this. So sodium chloride, what kind of compound is this, guys?
Ion.
It's an ion. It's an ionic compound, right? It dissolves into sodium ions and chloride ions, and we get two particles. Breaks up into sodium and chloride. Okay? Calcium carbonate. What is this carbonate thing called? Polyatomic ion. Yes, carbonate is a polyatomic ion, and calcium is a regular monatomic ion. Breaks up into two particles. Even though there's more atoms in this molecule, it still only breaks up into two particles. Calcium and carbonate. Okay? So you'll need to still remember your polyatomic ions, right? And know what things break into. So this one, sodium nitrate, also breaks into two. Okay. Magnesium nitrate, it has this little subscript here, 2, that refers to 2 nitrates, right? Okay, so how many particles is that? 3. Okay, because I is a direct multiplier in these, the more particles it breaks into, the bigger effect it's going to have. Okay, so if I want to depress the freezing point by adding salt, okay, that breaks into 2 particles, and that will depress the freezing temperature. If I use calcium chloride, which is, let's see if I can put that in here somewhere, calcium chloride, how many particles does that break into?
2, yeah, wait, 3. Let's use 2.
How many particles do you guys?
No, wait, no. It's 1 because it's covalent.
It's not covalent. It's still ionic. Chloride is always, see, you can tell it's ionic because there's a metal and a non-metal still.
Oh.
But, okay. So I'm going to break off my calcium. That's 1 particle. And then what's left?
2
2 chlorides. Yep. So I have 2 plus 1 is 3 particles. Okay. I know, this is applying a lot of things you've learned.
I don't know what 2 plus 3 is.
But so if I use calcium chloride in my ice cream maker, it would be more effective. It would drop the freezing point more than sodium chloride. Because the multiplier would become 3 instead of 2.
Salt is easy to come out of.
Okay. Yes, salt is much cheaper. Sodium chloride is much cheaper and much more accessible to you guys than calcium chloride.
I mean, liquid nitrogen would be more effective.
That's true.
Okay.
Okay. Okay. Now this one here,
The chemical store.
this is sugar. Okay, C2H6O2. It doesn't, it dissolves, right? But it dissolves molecule by molecule. The whole molecule stays together. It's not breaking into particles. So it has a I factor of 1 because it's just going the whole molecule. Sugar. It's a covalent molecule. It doesn't split into ions. Okay.
Just rearrange carbon, hydrogen, oxygen. A lot of things.
Okay, so here's a sample problem. We're gonna try and solve for the molality of a sodium chloride solution. All right, and you need to memorize this equation. Delta T equals negative I K sub F little m, which is the molality, okay? We'll go through and solve that. Okay, if I'm told that the delta T, it's gone down minus 15 degrees Celsius, that's the freezing point is decreased by 15 degrees when the salt is added. Generally, these are done as word problems, and you need to recognize, oh, it's saying the freezing point has decreased. So I write down delta T equals negative 15. All right, K sub F. This one is in your book. This is the K sub F that I said, just memorize this. 1.86 degrees Celsius per molal.
Yeah.
But that was looked up in an experimental table.
Question mark.
Okay, what is I? Well, I equals 2 because of sodium chloride, right? It breaks into 2 particles. Okay, now I've got delta T, I've got K sub F, I've got I. And I can solve it using algebra for the little m, molal. Okay, watch your negative sign on a freezing point depression one. Rearrange it. So what I like to do is always rearrange my equation first. It's easier to put the numbers in. Delta T over negative I times K sub F is going to be your molal. Then I just plug in the numbers. And so see, this is why you got to watch the negatives, because I've got a negative 15 delta T, and then I've got the negative I, and those are going to cancel out. If I end up with a negative molal, check your negative, right? There's no such thing as a negative concentration. All right? And, okay, so then looking here, this is what my calculator tells me is 13.95. But now I'm going to go back and evaluate for significant figures. And you don't use I because that's a direct counting number. It's like counting eggs, right? So we don't use this one significant figure. I've got 2 significant figures in my temperature, and I've got 3 here. So I want my answer in 2 significant figures because that's the lowest. So I'm going to round up to 14 molal. Does anybody have any questions on this?
Rearrange. Wait, so you have the negative on the K at the bottom, but you said there were 2 negatives to cancel out. Where's the second
Yes.
negative?
So the negative 15, because my temperature
okay,
was
okay.
depressed. My final temperature was lower than my initial temperature.
Depressed temperature. Really sad. And I totally stole that from Carol.
What?
Nothing.
What?
Oh my god.
Wasn't saying
Okay,
she's
is that the end of the
depressed,
notes?
I said
That is the end of the notes. And we
She's
will
like,
probably
Was
have
there a missing
time.
page of the notes that we just did not
The
have?
vitamin zero.
Yeah,
Actually, no, that
No.
just confuses
Because
me.
everything you just went over was
It's just
not on
like-
these papers.
Are you sure?
All these
What did I just hand out?
You handed out notes.
Don't worry.
So,
I wrote it all down.
Was it on there?
No.
No.
Show me what I handed out.
Back.
This?
Yeah, that's it. Yeah, the front and the back.
Yes, you're missing.
Rita.
Yep, you're missing a page.
Okay. She never gave it to me.
You guys, stop me!
I thought it was
It's
purposeful.
fine.
I will print it out. I will print it out. But
I thought it was purposeful.
okay. Let me pull it up and I'll print it out for you guys, and then I'll pull it back up. We have extra time today, anyways.
Totally works. It'd be a
I
good
already
house 'cause
wrote it
it's
down.
but science.
Okay, so you have that page. Do you have this page, freezing point depression?
Yeah, that's the back of the first page.
Okay, boiling
Oh, I
point.
know what we're
Okay.
gonna do.
That's what we don't.
This is the one that you don't have. Okay. Your sample. No. Let me see again. Yeah, you have all this. Okay, you just don't have the sample problem. Okay.
Yeah.
All right. All right, let me print this out.
We're over here just like, oh, don't worry about it. He's getting moved really good. It's just, it's really nice.
Page.
Basic. And people would like it, but it would hurt a lot.
Hours of work.
Oh, I saw my
Walking
brother do
5
this
minutes.
experiment 2 years ago, and I still remember what it did.
You do?
Yeah, instead of doing it with beakers, he had a little. He used the cap of a Coke bottle instead, and he put the water in there, and then he used little tongs to bring it up and put it in the boiling.
Tiny,
and then- Yeah, it was really tiny, and you could barely see the results, but.
All right, so we are gonna stop and work on our lab. We'll take a little 10-minute break first, and then at the end, we're gonna sit down and talk about it, and we'll probably work on some sample problems, some homework problems we'll work about. Okay, so let's, go ahead and take a 10-minute break.
Hey,
Not much.